So, like we just talked about, by definition, coulombs is the metric unit of charge, named after Charles Coulomb, who came up with Coulomb's law. Joules is the metric unit for energy, in honor of James Prescott Joule, Scottish engineer who did measurements with steam engines and heat. And then finally, voltage, is a unit of electric potential, which is energy per unit charge, joules per coulomb, in honor of Alessandro Volta, father of the modern electric battery. So another analogy to help you understand this abstract idea of electric potential. So again, electric potential is potential energy per charge. So here's what's weird. If you rub a balloon on your hair, it could actually generate a voltage of like 5,000 volts. So what's weird is it's not like you're afraid of this balloon that you just rubbed on your head. It's not this balloon of death. You're not going to run around the hallways chasing people. Had this static balloon of death. So it's kind of like when you play with a sparkler in the summertime around the 4th of July. Technically, some of these sparks could be up to 5,000 degrees Fahrenheit. So what's weird is this safe? Is it dangerous? And the answer is, yeah, it's totally safe. That's why you let kids, play with sparklers or rub balloons on their hair for static electricity experiments. And the reason why is because the total energy is small. So again, when you rub your head on the balloon, true, there's a lot of voltage, but the actual amount of charge and the actual amount of energy is very small. Same thing with the sparkler here. Yes, this is very high temperature, the internal energy per molecule, but the actual amount of energy present isn't enough to burn you there. It's not a big bonfire there. So maybe another analogy is, again, voltage is like electric pressure. So sure, 5,000 volts is a high voltage. It'd be like a squirt gun. So it's got a lot of pressure, but it's not going to be enough water to put out a fire. You need a fire hose, which would be a lot of pressure, but a lot of current and energy flowing. So the technical term, flow of charge rather, is called amps in terms of the units, amperes, which we're going to look at in our next unit when we study electric currents. Next, we have a voltage example problem. Let's check your understanding. So question reads, find the electric potential, which is a fancy word to say voltage, of a Van de Graaff static generator. Classic physics demonstration to demonstrate electric fields and electric potential, which has 1 joule of energy, but only 0.000001 coulombs of charge. So this is 1, 2, 3, 4, 5, 6. Or in other words, 1/millionth of a coulomb of charge. Or you could say 1 microcoulomb. 1 times 10 to the negative 6th, or 1e negative 6 would be another way to write that out. So let's give you a minute, see if you can figure this out.